Okay, section 4 of chapter 10 on inscribed angles. What does inscribed mean? Remember that? We learned that word last video. It means to be written, to be scribed, scribbled, drawn inside. So these are angles drawn inside a circle. Remember, this whole chapter is on circles. So we're going to be finding the measure of inscribed angles, finding measures of inscribed polygons. A new word you'll need to know is intercepted. What does it mean to be intercepted? So the definition of an inscribed angle is an angle whose vertex is on a circle and whose side contains chords. Okay, on a circle. So remember, if it was in the middle of a circle, this was called, why does that do that every video? This was a central angle because the vertex was the center of the circle. This time, inscribed means the vertex is actually on the circle. So it's touching the outer rim of the circle. That's what makes it inscribed. The arc that lies in the interior of an inscribed angle and has endpoints on the angle is called the intercepted arc. So the intercepted arc is this part of the circle, the arc, that goes from endpoint to endpoint on that circle. The endpoints lie on the angle. So it's the piece of the crust, so to speak, of the pizza goes from one side of the angle to the other side of the angle. Okay, so here's perhaps a better picture. The inscribed angle here, notice the vertex is on the circle. The intercepted arc is the piece of the circle that is cut out if you were to cut this inscribed angle. So you need to know those two terms, inscribed angle and intercepted arc. Okay, relationships here between the inscribed angles and the intercepted arc. The measure of an inscribed angle is half of its intercepted arc. The angle is half. Okay, so remember, on the central angle, this measurement equaled this measurement. Well, if we back that up, if we were to back this vertex up all the way here and make an angle that intercepts the same arc, would this angle be smaller or bigger than this central angle? Obviously, it's smaller. How much smaller? It's half the size of that other one. So in this picture, x is going to equal half of y. Or you could say y equals twice x. Remember, you can say it either way. Okay, so let me erase my drawings here. I know I get carried away. I like to mark up stuff. So in this picture, the measure of angle ABC, here's ABC, this angle right here, is going to be half of this arc, ADC. Or you could flip it around and say angle or arc ADC is twice the measure of this angle ABC. Same relationship, you're just saying it different ways. So let's work some problems. If the arc WX, so we got to find that first, is 20. XZ here is 40. UZ all the way around here is 108. And UW from here to here equals, okay, so we're going to put some congruency marks here. So we have everything around the whole circle accounted for. Find the measures of the numbered angles. Well, I'm going to take these arcs and I'm going to fill in these unknowns right here first. Because if I know my arc measures, I can find my angle measures. Okay, so 20 plus 40 is 60. plus 108. So I have a total of 168 plus 2 times my unknown, because these are the same, they're congruent. That equals the distance all the way around my circle, which is 360 degrees. So 2x is going to equal, what, 198? I mean 192? 192, 292, 360, yes. Divide by 2, divide by 2. So x is going to equal 96, 18, yep, 96. So this is 96, and this is 96. Now remember, central angles equal, but inscribed angles are half. So let's see if we can figure this out now. Angle 1, let's just go in order. Angle 1 is going to be half of the intercepted arc. So I'm going to follow this all the way out. And if you need to extend these sides so you can actually see the arc that's between it, it's this 96 that falls between there. So it's going to be half that. So angle 1 equals half of 96, which is 48. Angle 2 is right here. Follow these sides all the way out, and you will see that they encompass xy, which is 40. So it's going to be half of 40, which is 20. Angle 3, again, visually carry these sides all the way out. It intercepts the arc of 108, so angle 3 is going to be half of 108, which is 54. Angle 4 is this angle right here. It goes from here to here. Okay, well that involves two arcs, 96 and 20. So we would have to add those together and get 116. Half of 116 is what? 58. And then the last one, angle 5, is going to go from U to Z, which again is 108. So it's going to equal 54 as well, just like angle 5 or 3 here. Right? So just using that simple relationship there allowed us to find all of these. So let me clear this, and you can see the more professional fill-ins. Okay, 108 there, just like I did with the pen. So we add them all up to 360. Solve for A, which is 192. 2A is 192, so 96 each there. And now we just fill in what we know, half. Half of 40 is 20. And so on. So there are your answers and how to get to them. Okay, so you can back it up, watch it again, see if you can do it on your own. Or if you think you got it, keep going. Okay, remember, these videos are for your benefit. You can pause them, back them up, watch them as many times as you need to get the concept down. Okay, here's another one. Again, I'm going to fill in what I know. X, Y over here is 60. Y, Z is 80. WX is equal to WZ. So I'm going to put congruency marks there. Find the measure of angle 1. Okay, well, as long as I can add all this up to 360, I'm good. So if this is X, this would also be X. So my equation would be 80 plus 60 plus X plus X. Well, 80 plus 60 is 140. X plus X is 2X. That equals how much in the whole circle? 360. When I subtract the 140 from both sides, I get 220. So x equals 110. So this arc is 110, and this arc is 110. Now, I really didn't need to know that for this problem. I'm anticipating that perhaps we're going to use the same circle in a few problems, so let's just go with it here. Okay, angle 1 is an inscribed angle because its vertex is on the circle. It extends through x and through y, so I look at the arc that extends from x to y, and it's 60. My angle is going to be half of 60, so my correct answer should be 30. Okay, same situation again. So we already found 60, 80, and what were the other two? Do you remember? 110. So now we need to find angle 2. Okay, angle 2 goes from y to z, so I need this arc, 110. It's an inscribed angle. It's going to be half of 110. Half of 110 is 55. Okay, same circle again, 60, 80, 110, 110. This time we're looking for angle 3, so it goes from z to y, which encompasses the arc or intercepts the arc that is 80. Half of 80 is 40. Continue on to angle 4. Okay, this was 110. Angle 4 is going to be half of that. Remember, it extends through the y and through the x, intercepting this arc. B is our correct answer. Okay, I encourage you to pause here. See if you can find angle 5. Remember, we had 60, 80, 110, and 110. So what would the measure of angle 5 be? Pause and figure it out yourself. You should see that angle 5 right here goes from W to X, intercepting the 110-degree arc. Divide that by 2, and once again you get 55. So I hope you got it right. Here's another rule, theorem. If two inscribed angles of a circle intercept the same arc, or congruent arcs, then the angles are congruent. Because again, let's say that this arc was 60. Well, y intercepts that and is an inscribed angle, so it would have the measure of 30. X is an inscribed angle intercepting that 60-degree arc, so it would have an angle measure of 30. So therefore, they would have to be the same every time. So in this picture, angle X is going to equal angle Y. Sometimes it gets kind of confusing to see, so try to visually isolate what you're being asked about. Angle DAC. DAC is this angle right here. Remember, A is in the middle. That's our vertex. And DBC. D to B to C, B being our vertex. So if you follow these angles out, and I follow this one out, if I do it in a different color, it might be easier to see. You see that they intercept the same arc, so they're going to have the same measure. Okay, here we're going backwards. We know that they're intercepting congruent arcs, therefore we can say the angles are congruent. Okay, so if the angles are congruent, the arcs are congruent. If the arcs are congruent, the angles are congruent. So this angle is the same as this angle. FAE is the same as CBD. because FE is congruent to CD. So let's use these ideas and see if we can solve for some unknowns here. Okay, arc WX, this big arc here, is going to be 104. And then arc WZ over here on the left is 88. We also know that the measure of angle ZWY, so ZWY has W as the vertex, but it's this one, it's this angle 2 right here. It's not the whole big one, dang it. It's not this whole big angle, it's angle 2 here, is 26. Find the measure of each angle. Okay, well, how are we going to do that? Angle 1, let's just go in order. Angle 1 intercepts this 104-degree arc, so we just have to cut that in half. Wait a minute. Let's go backwards. Find the measure of each angle. Okay, so this is going to be 52. Let me get these markings out of the way here. Okay, because it's half of that 104. Let's see, 3, we can't directly find that out yet. 4 we can find out because it intercepts this 88. So that's going to be 44. 5 we can't find yet. 6 also intercepts the same WX, so it's half of 104, which is 52. So now we got to figure out how are we going to find angle 3 and angle 5. Okay, well look, angle 5 intercepts the same arc as angle 2 does. So it has to be 26, just like angle 2. Now there's really a couple of approaches here to find angle 3. We could find all of these arcs and see what's left over here. And I know this arc is 104. I know this arc is 88. I can find arc ZY because I know it's intercepted, or its inscribed angle is 26, so that means the arc is going to be twice that. Twice 26 is what, 52? How would I find what's left of my circle? I really want you to be thinking about this, not just waiting for me to give you the answer. We know that the whole circle is how many degrees? 360. So I'm going to add up what I know plus my unknown, and then that's going to equal, 360. Here we get, these two would be 192 equals 360. Add those together and we get 244 plus x equals 360. If I subtract the 244, I get x equals 116. So that means over here is 116 degrees, this arc from y to x. Angle 3 that intercepts that 116 degree arc is going to be half that. So angle 3 is going to equal, what, 58? Okay. Now let's look at my professional version here. I like to show you how I think things through, even though you may not see it the same way I do. Some people don't see it at all, and it just helps a lot of my students to hear how my brain works and how I think it through. Okay, so here's another way. Same thought, just in a different order. We took 26, multiplied it by 2 to get 52 here. Then we found this missing arc here by adding everything together, just like we did over here, and getting 360. Cut to the chase, and it became 116. Once I had all my arcs filled in, I can just divide them by 2 and get all of my angles. So angle 1 was 52. Yep, that's what we had. Angle 2 was given to us, 26. That's easy. Angle 3 was half of the 116. Yep, we got 58. 44 for angle 4, because half of 88. Angle 5 was half of the 52, which is 26. And angle 6 was half of the 104, which is 57. No, that's not right. That's 52. Okay. Here's another inscribed angle line. This is a special case. It still follows the same rule, but it's a special case if you will recognize it. What kind of chord is this AB if it goes through the center of the circle? Hopefully you recognize this as a diameter, which cuts the circle in half. So this arc, this intercepted arc AB, is a semicircle, 180 degrees. If our inscribed angle is half that, it would be a 90-degree angle. So the shortcut is that if you're intercepting a diameter, an inscribed angle is intercepting the diameter, it's going to be 90 degrees every time. A 90-degree inscribed angle intercepts the 180-degree arc. So angle C is a right angle. If and only if AB is a diameter. Keyword there, diameter. Okay, so if we didn't give you this right angle box, you should still know it. It's an assumption you can make. It's not really an assumption because it follows the rule, right? So this would be a right triangle. You have one leg is 3, you have one leg is 4. If you recognize that as a Pythagorean triple, 3, 4, 5, then you know that that diameter is 5. And so I could ask you that. I could ask you what's the radius? Well, it's going to be half that. Okay, all different kinds of things we could ask using this relationship. So let's do some. Triangle TUV and TSU are inscribed in circle P with VU being congruent to SU, so I'm going to mark that. Find the measure of each numbered angle. 2 is x plus 9. It doesn't look like an x, nor does it look like a 9. 4 is 2x plus 6. Okay, so what do I know about angle 2 and angle 4? Well, they are the acute angles of a right triangle. So that means they have to add up to 90 degrees. So 2x plus 6 plus x plus 9 has to equal 180 degrees. Whoops, has to equal 90 degrees. My bad. Okay, so there's our acute. I need to just quit writing and do my computerized version. Okay, so if I subtract the 90, I get, combining like terms there, x equals 25. So if I plug it in to angle 2, I get 34. If I plug it into angle 4, I get 56. Because these are the same triangle, because they intercept the same arc, then angle 1 is going to equal angle 2, same measure, and the same thing for angle 3 and 4. They would both be 56. Okay, why do I know these are the same angle? Why do I know these are the same angle? They intercept the same arc here. Okay, these are congruent arcs. Angle 2 intercepts US, angle 1 intercepts UV. Them being congruent means that these two angles are congruent. Let's do one more here and then we'll move on. Triangle MNO and MPO are inscribed. MN is congruent to OP. Find the measure of angle 1 if the measure of angle 2 is 4x minus 8 and the measure of angle 3. Okay, do I really need to know this information here to find angle 1? If it intercepts the diameter, I should not even calculate anything, because if I remember the rule, if it intercepts that diagonal, it's automatically a right angle. Okay, so sometimes you're going to have extra information. Okay, let's move on because this is already getting kind of long. We'll work some more examples in class. But remember, you can always go through this and pause it and work some on your own. In fact, I highly suggest you do the last two that way, using those rules. Okay, inscribed polygons. This is a reminder, inscribed means to be drawn inside. A polygon is drawn inside the circle. The circle is circumscribed about the polygon. It's drawn around that polygon. If the quadrilateral, okay, this is specific to quadrilaterals. How many sides are quadrilaterals? 4. This is like a square, a rectangle, a trapezoid. Remember, they have to have all vertices sitting on the circle. So it has to be something like this, where all 4 vertices are on the circle. Could be inscribed in a circle if and only if its opposite angles are supplementary. What does supplementary mean? Adds up to, key phrase, adds up to 180. So quadrilateral ABC is inscribed. Opposite angles mean you're going diagonally, so B plus D is going to equal 180. A plus C is going to equal 180. So we're going to use that here. What would X be? Well, what am I going to do to these two? Are they opposite angles? First of all, you got to ask yourself, are these opposite angles? Yes. Therefore, I would add them up just the way they're shown there in the quadrilateral and equal them to 180. Combine like terms. 5x minus 5 equals 180. Move the 5, then divide by 5, x equals 37. Now I could have asked you for the two angles, in which case you would need to plug that back in. Okay, here's another situation. They could give you words, in which case you would need to draw a sketch. So they give you circle M, so M's in the middle. You have QRST inscribed, so all 4 of those points need to be touching the circle in order to be inscribed. If we know Q is 87 and R is 102, find S and T. Well, what do we know about Q and S? They are supplementary. So 87 plus some number has to equal 180. That some number is going to be 93. What do we know about R and T? They are supplementary. 102 plus some number is 180. So X equals 78. Okay, just add up the opposite corners. Here's another one. Okay, you need to draw it if you can't see it. We have circle X. And triangle BCDE, or triangle quadrilateral, BCDE. Remember, they have to go in order. 99, 76. So we're going to do opposite B and D. So 99 plus some number equals 180. X is going to equal what? 81. Is that angle D? Yes. So the correct answer is C. Okay, you do this one, pause, draw it out on your paper, solve for E. Correct answer is 104. Hope you got it right. If not, ask me about it tomorrow. Okay, that's it.